Alright students, we've learned what spatial databases are and how indexing makes them efficient. Now, let's move on to the most exciting part, that is applications of geographic databases. Where are these spatial databases actually used in the real world? And the answer is almost everywhere, from city planning to Google Maps, from telecom towers to even military operations, spatial databases are quietly running the show. Let's go through some of the key applications one by one. First, urban planning and management. Imagine building a new city or even redesigning a metro road for Pune. You can't just randomly put roads or buildings anywhere, right? Planners need data about land use, population density, water pipelines, electricity grids, and green zones. This is where geographic databases come in. They store zoning information like residential, commercial, industrial areas, help design transportation systems like roads, metro lines, bus routes, even support utilities planning like water supply, drainage, power lines. They even simulate future growth patterns of the city. For example, before building a flyover, planners can use GIS data to predict traffic flow and environmental impact. Next, transportation and navigation systems. This one you all know very well because you probably used it today. Apps like Google Maps, Apple Maps, Ola, Uber, and Zomato Mapping rely heavily on spatial databases. They calculate the shortest routes between two locations, provide real time traffic updates using live GPS data. Governments use them to design better road networks and monitor congestion. Logistics companies like Amazon or Delivery use them to optimize delivery routes. Think about it, without spatial databases, your cab app wouldn't even know which driver is closest to you. Next, tourism and recreation. Let's say you're planning a trip to Goa. Wouldn't it be nice to see all the beaches, hotels, restaurants, and tourist spots on one map? That's exactly what spatial databases do for tourism. They map attractions, hotels, and heritage sites. Tourists can use interactive guides and plan trips based on proximity. Parks and wildlife reserves use them to manage visitor flow and protect the environment. For example, ever noticed how travel apps like TripAdvisor or Make My Trip show nearby attractions? Yup, that's powered by spatial databases. Next, telecommunications. Now here's a less obvious one. Telecom companies. To give you strong network coverage, they need to plan where to place towers, cables, and fiber lines. Geographic data helps analyze terrain, hills, rivers, valleys. Population density is studied to decide where more towers are needed. Engineers identify signal gaps and optimize service. Fault detection and maintenance planning also rely on spatial analysis. Next time your 4G or 5G signal is strong, remember there's a spatial database somewhere helping the telecom provider plan that coverage. And finally, one of the most critical applications, defense. Defense forces rely on geographic databases for mission planning, surveillance, and battlefield awareness. They provide detailed terrain maps for soldiers, track enemy movement with the help of satellites and drones. Weather in terrain data improves decision making in real time, helps in deploying troops and equipment strategically. In short, geospatial intelligence can literally make the difference between mission success and failure and also save lives. So students, to summarize, urban planning, designing better cities; transportation, navigation apps, traffic control, deliveries; tourism, mapping attractions, trip planning; telecommunications, network planning and optimization; defense, surveillance, mission planning, intelligence. Spatial databases are not just a theory chapter, they are powering so much of the world around us. Alright, so that brings us to the end of this unit, spatial databases. We've covered what spatial databases are, how spatial indexing works, and where they're applied. In the next section, we'll take a closer look at numerical problems and spatial indexing techniques with spatial queries, the actual commands and examples you can run to interact with these databases. So any question before we wrap up today?